So this one's lesson 10, but I know like some others might be working on a different practice. You can still ask questions. But on lesson 10, a group of hikers is progressing steadily along an uphill trail. The graph shows their elevation in feet at each distance from the start of the trail in miles. And first, we want to know what the slope is. Do we remember what the equation is for slope from a graph? Rise over run. Good. There's also a few others. And we didn't really have time to talk about them today, but I'll tell you them now because it might make this problem easier. So we have rise over run. There's also y2 minus y1 over x2 minus xy, or change in y divided by change in x. They all give us the slope, which is m. Now, when it's from a graph, usually I recommend rise over run, but you'll see some of the pitfalls when the graph has like really big numbers here. But let's see. Anytime you're trying to use rise over run, or even this one, the y2 minus y1 over x2 minus x1, you want to pick points that you can see like really clearly. So like you want to pick them, like if this is like my grid lines, you want the line to be touching like right in the center of the points you pick. Because if I pick like this one, and I'll mark it in like green, I would have to estimate that one, and I'd rather not, because that might mess off my numbers a little bit. So I'll take this one that I marked in red and this other one. And when you find 2 points, and it can be anywhere, they could be far apart, they can be close together. Closer is probably a bit easier because then you'll have to do less reducing. But you find it and maybe you visualize it since you can't actually draw on your computer screen. But count your rise. So if I'm going from 2,000 to 2,500, how much did I go up? What's my rise going to be? Well, it would be 1 if this was going up by 1. 500, good. That's my rise. And then looking here, and these count by 1s, what's my run going from 6 to 8? So then rise over run would be 500 over 2. And you always want to make it like the most simplified it could be. What is 500 divided by 2? So it could be a fraction, like it's allowed to be a fraction, but you just want to make it like the most reduced fraction. This one reduces to a whole number. So then let's see, 250 is in my options. You'll pick that one. All right, because if you just did 500, you're not dividing by your one. Okay, so now let's see the other one. What does the slope tell us about the situation? So generally, and this will probably work in any situation, slope is what it's changing by each time. So it looks like as they're traveling along, each mile that they're going up, so if I just look at one increment, it's going up by 250. And then if you look at the next increment, it's another 250 that it's going up. So slope is always what it's changing by each time. Let's see what it says for our options. It tells us how many feet the hiker's elevation blank for each mile they hike. So is it increasing or decreasing? Increasing. You can tell for 2 reasons. One, our slope was positive. And you can also tell just from looking at it right here, it's going up from left to right. So that's a positive slope as well. All right, so there's that. Which equation represents the relationship between the hiker's distance from the start of the trail and their elevation y? So from the start of the trail to, okay. So another key point on your linear graphs, aside from the slope, is what? Especially for using slope-intercept form. Your y-intercept. And that makes sense because that gives us like our starting amount. So slope is always what it changes by, y-intercept is always your starting amount. So at 0 miles, they were already 500 feet in elevation. So that's where they started at. Now, if I was putting this in slope intercept form, which is what my answer options are in, so let's do that. We already said the slope is 250, and then looking at this, what's my y-intercept? 500 is my y-intercept. So then I'm gonna put that for the b, because the b in y equals mx plus b is for our y-intercept. So let's see which one matches that. All right, on mine, it's the first one, 250. Oh wait, no, that's incorrect. Why is this one incorrect? I know it's hard for you to see probably where you're at. Oh. Yeah, so this one tried to trick you by putting the x with the 500 when really it needs to go with the 250. So really actually have to pick this one, and even though it's in a different order, the order doesn't matter. It's what's with the x, like, has to stay with the x. So like the x has to go with the 250. That's your slope. It will be times by whatever x is. Your y-intercept should always be like alone. It should always be a constant. Because it's not changing when you're starting to make sense. All right, so that's a good one. And then down here, does the equation represent the same relationship between the distance from the start of the trail and the elevation? So to see if this is equivalent, what you really are doing is seeing if I could rearrange this, which we know is correct, into this somehow. Because you can do whatever you want as long as you do it to both sides. So it looks like they moved the 250x to the same side as the y over here. What would I have to do to move it? Like what math? If I want to cancel out the 250x on the right side, how would I do that? You would subtract 250x from both sides. Because they're like together, they're a term, right? So that would get rid of it on the right side, which would be why the 500 is alone. And then these two are not like terms. This one has a y, this one has an x. So you can't like combine them. Really, you're just writing them next to each other. And since that matches what this is, and we followed like the math laws, like we subtracted it on each side of the equal sign to keep it equal, then I would say that yes, that does describe the same relationship. That makes sense? I really like that question. Any other ones? From any practice, really. The last one, what does it start with? So we have a soccer team holding a car wash in a part of town with a lot of car and truck traffic. The team spent $90 on supplies. They plan to charge $10 per car, $20 per truck. Their goal is to raise $450. How many cars do they have to wash if they wash the following numbers of trucks? So I've seen students do this, like just kind of like this express word math. But really, if you made an equation, it would make your life a whole lot easier, in my opinion. But I've seen students like, they'll say like, okay, well, if there's 4 trucks and they charge $20 per truck, that would be $80. And then let's see. Yeah, they want to raise $460, and I don't know if that includes the 90 or not that they already spent. So let's see. then they would probably subtract 80, which is what they get from that. Plus 380. And then they would probably divide that by the amount they charge per car. But I do think that they want to include the 90 as well, so let me see. Because if we were making this a linear equation that could work for no matter like what situation, then they're probably starting with the minus 90. So let's see, I doubt it's gonna be 38. Yeah, it's not. All right, so they are including the 90, which is what I thought they would do. And that's why I said like making the equation is probably gonna be like your best bet. So slope is always like what it's changing by each time. So we're solving for the number of cars. Or let me actually put it in standard form. I feel like that would be easier. Maybe not. What's 460 plus 90? Anyone? 550. I think it's 550, but I'll just check because I don't like doing mental math. Okay, yeah, 550. So then if we minus the $80 from that, which is 470, and then we'd have to divide the 470 by 10 because that's how much they charge per car. Then I'm doing 47 cars, which is one of the answers. So every time I put like a right answer in, this goes up. So yeah, that's how you're doing it. You're having to account for the $90 that they already spent and add that to what they want to raise. So that way you can actually get how much cars you need. Does that make sense? Okay, let's see if anyone has another question, we could do that one since the same process. Now it's just you're doing 15 times 20 and then subtracting it from 550. Any other questions? Okay, then we can continue with this one. All right, so then when it's 15 trucks, how much money are they making from just the trucks? All right, that is correct. And then we're having to subtract that from the 550. And then dividing that by 10 because that's how much they're charging for the cars. So I get 250 from subtracting it. 250 divided by 10 would mean how many cars do they need to wash? 25. So I usually will see people reason it that way. But if you made the equation, then that might be easier. Like they're charging $10 per car and $20 per truck. And that's giving me my total raised, which it would be the 460 plus the 90 that they spent on supplies. And then you could do, you could rearrange it to make it easier to solve for the number of cars. Or you could just plug into this equation. Or you could reason with the math. It's as long as you get the right answer at the end of the day, it doesn't really matter.
This last one just one.
Let's see, 27 times 20. So yeah, just one car. So that's 3 out of the 4 answers. You guys can solve this one.
when it's 21 trucks yourself, how many cars?